Hello, this is Professor Eckhouse, and I am talking about the second half of exponent rules today. So we're going to start with simplifying negative exponents and exponents of 0 and 1. So actually we're starting with exponents of 0 and 1. So let's look at x to the 3 over x to the 3. So think about what you typically would do with this. What would you typically do? Well, every single one of them cancels out, and we get 1 times 1 times 1, which is just 1. So, we get 1. So what did we do with the exponents? So let's think about this. So let's think about this as and. And there's another way to think about it. X to the, because this is a quotient, right? That's a quotient. We get x to the 3 minus 3. So that is x to the 0. So this means that x to the 0 must equal 1, right? Because we did it two different ways, and we got two different things, so that means they're both equal to each other. So that means x to the 0 equals 1. So that's our 0 exponent rule. X to the 0 equals 1. That means any base to the 0, any base. I could have 1 million. Ooh, what did I just do? 1 million. And I take it to the 0 power, it equals 1. Okay, it doesn't matter what you take to the 0, it is 1. So let's try some. All right, so simplify using the 0 exponent rule on all of these. All right, once you pause it, see what you get. All right, so I'm going to take these a long way around, just so you can see the y of everything, even if you're used to just canceling things out. So on this one, we've got 5 times x to the 2 minus 2. Right, using the exponent rules of the quotient rule. All right, so we get 5 times x to the 0, and then that means we've got 5 times 1, which is just 5. Okay, so in the past you may have just said, oh, those two cancel, but this is why they cancel, another reason why. Okay, all right, so we've got x to the 5th over x to the 2 times x to the 3, which means x to the 5th. So we've got x to the 5 minus 5, which is x to the 0, which is 1. Okay, so again, I said I'm taking these a long way around because I want you to see the y behind all of this. We've got 7 to the xy squared to the power of 2 minus 2, which means we get 7 to the times xy squared to the 0, and that means everything right here equals 1. So we get 7, and that's a 0. 7 times 1, which is 7. Okay, so now let's look at negative exponents. All right, so we've got x to the 2 over x to the 5. So if we do this by showing every bit of it, we get x times x, and on the bottom, x times itself 5 times. All right, so what cancels? We've got that one cancel and that one cancels. So we get 1 over x cubed. Okay, 1 over x cubed. Well, let's do this the other way. Let's think about this as x to the 2 minus 5, and that is going to be x to the minus 3. Well, that means these two are equal. That means that we just decided, by doing it two different ways, getting two different answers, that they must both be equal. X to the minus 3 is the same thing as 1 over x cubed. So the rule is x to the negative a is 1 over x to the a. This one often takes some stopping and thinking, so feel free to do that. All right, so let's try some problems. So why don't you pause the video and give these a try. All right, so we've got x squared over x to the 8th is x to the 2 minus 8, which is x to the minus 6. That is not considered simplified. No negative exponents when we simplify, so that is 1 over x to the 6th. All right, the next one, x to the 3 times x to the 4, is x to the 7 over x to the 10. So that is x to the 7 minus 10 using the quotient rule, which is x to the minus 3. Now we're not done because that is not considered simplified. 1 over x to the 3 is considered simplified. Okay, now we're going to combine rules. So try a couple different ones here and simplify these two. All right, so we've got x to the 5 times x to the minus 12, which means we're going to use the product rule. So 5 plus negative 12 is 5 minus 12. So we've got x to the negative 7, which is 1 over x to the 7. All right, the next one is z to the 7 plus negative 7, which is z to the 0, which is 1. All right, the next topic, simplifying compound expressions. So think about what xy cubed means. It means xy times xy times xy, which if I rearrange this, because we can rearrange algebra, there's no multiplication, we can rearrange because there's no addition or anything in there. So we can say x times x times x times y times y times y, which is just x cubed times y cubed. Okay, so this leads to that. All right, so our rule is xy to the a is the same thing as x to the a, y to the a. And that one is usually a little bit more intuitive than some of the others because you've kind of been doing that probably in algebra already. All right, so let's try some examples. Try simplifying all 4 of those. All right, so first one. This is going to be x squared, and then so that's going to apply to that, and then the 2 is going to apply to this one. So let's take this the long way, and then we get y cubed squared. So we're going to use the power rule, x squared times y to the 6. And we can just write that as x squared y to the 6. All right, next one. So we're going to have 2 to the 4 times, what was that? X to the a to the 4 times y to the b to the 4. So this becomes 2 to the 4 is 16. X to the a to the 4 means a times 4, which we write as 4a. So x to the 4a, y to the 4b. And that's our final answer. All right, the next one is going to be negative 2 cubed times x to the 5 cubed. Negative 2 cubed is negative 8. X to the 5 to the 3 is x to the 15. Negative 8, x to the 15. All right, next one. We've got x to the minus 2 to the 6 times y cubed to the 6. So that becomes x to the minus 12, y to the 18. Now we need to make sure we take care of this because it's minus 12 on top is not considered simplified. So we're going to rewrite this. Y stays on top, y to the 18 stays on top, and x to the minus 12 brings the x to the bottom, like that. And that is considered simplified. All right, if any of those threw you, pause the video, take some time to think. All right, so very similar, finding the power of a quotient. So here we've got a over b squared means a over b times a over b, and we can just take those parentheses away, and we end up with a times a on top and b times b on the bottom, which is a squared over b squared. Okay, so the power of a quotient, rule of exponents, looks like this. We've got x to the over y to the a, so we get x to the a over y to the a. And there's our power of quotient rule. All right, so let's try some examples here. These are all starting to combine the different rules. So more examples because there's more things to think about here. So try all of those, or a little at a time if you'd like. All right, so the first one we get 2 cubed over z to the 8 cubed. So that becomes 8 over z to the 24. All right, the next one we'll get x to the minus 2 over y to the 4 to the minus 2. And you will get to where you can skip some of these steps, but at first you may not want to do that. All right, so we've got y to the 4 to the minus 2 is y to the minus 8. Now what are we going to do with that? So I want you to think about this. If we have a negative on an exponent, it brings it to the bottom. If it's already in the bottom, where do you think it goes? It's going to go to the top. So we get y to the 8 comes to the top because of that negative exponent, and then we get x to the 2, it goes to the bottom because of the negative exponent. Now, does anything cancel? People are tempted here to cancel. They are not the same base, so we can't cancel them. This is as far as we can take it. All right, the next one, we get negative 1 on top to the 21, and on the bottom, t squared to the 21. So negative 1 to a negative power is going to leave us with a negative 1. And then on the bottom, we get t to the 2 times 21 is 42. All right, last one. We have, make this a little bigger, we have x squared to the 3 over y to the minus 4 to the 3. So we get x to the 6 over y to the minus 12. Now, we've got a negative exponent, and it's in the bottom. That means it brings it to the top. So we get x to the 6th, y to the 12. And that's the final simplified answer. All right, that was the last of the exponent rules. So now I'm going to summarize them all. I would highly recommend that you have a piece of paper where you have rules and equations and formulas all in one place and have these all there. So what I'd like to challenge you to do is pause the video and try to come up with all of these rules without looking in your notes. All right, so hopefully you tried that. And let's write them all down. X to the a times x to the b, x to the a plus b. The next one, x to the a minus b. X to the a to the b, this is the power rule. X to the a times b. X to the 0 is always 1. X to the minus a means 1 over x to the a. And this one is x to the a, y to the a. And the last one, x to the a over y to the a. All right, so hopefully you've got those in your notes now, and you have them in a place where you can find them easily, and you'll use them regularly. All right, thanks for watching.